Hey guys, I'm here back with another math video. Today we're going to be doing a folding problem from ASHME 1991, problem 29. And right now, pause the video if you need to. Try to get familiar with the problem before I explain the solution. Okay, so here's the solution. So first we notice that triangle APQ is congruent to triangle A'PQ. And why is this? Well, when you fold a piece of paper, you basically take the paper that used to be in this space, APQ, and just literally just flip it over and reflect it to get A prime PQ, and it's just basically a reflected triangle. This is the same piece of paper that used to be in APQ space, but it's just flipped over and moved. So these two triangles should be congruent because that's just a property of folding. So since these are congruent and this triangle is equilateral, we know that this is 60 degrees, this is 60 degrees, this is 60 degrees, this is 1, this is 2, this is 3, I can count to 3. We want to find line PQ. How do we do that? Well, to find PQ, we might need some trigonometric rule. And you know what? 60, this is an equilateral triangle. 60 sounds like a really nice angle. And you know what? Since these triangles are congruent, APQ and A'PQ are congruent, this angle is also 60. So P'Aq is 60. And we can't really find PQ directly, but what if we found A'P and A'Q first? Because we can use the law of cosines to then find PQ. The law of cosines basically states that if you have angle theta, ABC, c squared equals a squared plus b squared minus 2ac cosine theta. So in this case, to find PQ squared would equal A'P squared plus A'Q squared minus 2 A'P A'Q cosine 60. And of course cosine 60 is just 1/2, so it's just 0.5. Okay, so if we find A'P and A'Q, we can then find PQ. And I don't want to keep writing A'P and A'Q, so we'll set these to A and B. So how do we solve for A and B? Well, first, you sort of have to predict that triangle A'PB is similar to triangle, let me think, QA'C. And you sort of have to predict that in order to prove it. So how do you prove these two triangles are similar? Because we'll use their similar relationship later to solve for A and B. Notice that angle B is already congruent to angle C. Whoops, angle C. So we already have one angle that's already proven to be the same. And that's one of the steps that you need for similarity. So what else can we do? We can see that, let's try proving that this angle is congruent to this angle. And let's just set this arbitrary angle to x, and let's try to see if these, in terms of x, if these two are the same. So this is x and this angle is 60. If angle A is 60 and this is x, this is 120 minus x, right? Because they all have to add up to 180, and 120 minus x plus x is 120 plus 60 is 180. Okay, that works. This is also x. And remember, it's because these two triangles, APQ and A'PQ, are congruent, so that's also x. So the straight line adds up to 180. 180 minus 2x, that is this angle. And what does that make this angle? That means a measure of angle QA'C plus 180 minus 2x plus 60 equals 180. And if you do some solving, you get measure of angle QA'C is just equal to negative 60 plus 2x. Okay, so this is equal to 2x minus 60 basically. Let's try proving that this angle is 2x minus 60. So this is 120 minus x, this is also 120 minus x, and then angle BPA' is 180 minus 2 120 minus x. And if you get that, that's also 2x minus 60. If you calculate it, so 2x minus 60. Which means these two angles are congruent. Angle BPA' is congruent to angle, what was it? Oh yeah, QA'C. So by angle, triangle A'PB is similar to triangle QA'C. What does this mean? it means that we can actually use these, since triangles that are similar have similar ratios to their corresponding side lengths, that means we can use these ratios to solve for A and B. And what do I mean by that? Let's see. That means that A over B equals PA prime over QA prime. And these are corresponding these are corresponding sides. Because since these two triangles are similar, PA prime and QA prime are actually corresponding sides. And two other corresponding sides would be this BA prime and QC. Because they're the short side of each triangle. And since the triangle is similar, these sides are corresponding. So the ratios are the same too. Which means that BA prime, which is 1, divided by QC. And what's QC? How do we put QC in terms of A and B? We want everything to be in A and B so we can solve for A and B. What's QC in terms of A and B? Well, let's see. Keep in mind, APQ and A prime PQ are congruent. So if A prime Q is B, AQ is also B. And since this entire side length is 3, that means that QC is just 3 minus B. This is 3 minus B. And we do similarly for BP. BP corresponds with A prime C. So what is BP? BP similarly is 3 minus A over, and of course A prime C is just 2. And what do we get when we solve this equation? If you do some algebraic manipulation and cross multiplication and some canceling out, which I will skip because I think you know how to do that, then we get that A equals 7/5 and B equals 7/4. Okay, now remember we want to solve for PQ by using law of cosines. So of course PQ squared equals 7/5 squared plus 7/4 squared minus 2 7/5 7/4, 0.5. And of course, if you just solve that, you get PQ equals 7 root 21 over 20. That's your answer. It's a pretty cool problem. I like it. You need to use some trigonometry. You need to use some similarity. It's a nice problem. It shows that even though a problem may look easy because it's just one fold, right? It can be actually quite hard. And occasionally there are folding problems that show up on AMC, AME, and USAMO, USJMO. I don't know which one, whatever it is. Occasionally these folding problems show up, and they usually make these geometry very complicated. So I hope you found some good knowledge that you learned and stuff, and I'll see you next week. Yeah. If this is x, this is going to be 1 over x. So this is true. So how does that help us? Okay, let's set some variables. Let's say A is cotangent -1, 3, B is cotangent -1, 7, C is cotangent -1, 13, D is cotangent -1, 21. Which means that if you take the tangent of all these, so tan A equals, if you take the tangent of this,